Hi class. I am today talking about chapter 2, picturing variation with the graph. So in this chapter, we're gonna try to have some graph and understand about it from statistic, right? So let's start with some topics in chapter 2. We're gonna try to visualize variations in in numerical and categoricals. So for the numericals, as you have learned in chapter 1, is about some data values with numbers. Could be a decimal or could be whole number, something like that, right? And categorical data is once something with characteristics such as like hair color, eyes color, and so on, something like that, right? For the visual variations in numericals, we're gonna learn this in 2.1, right? And for the categoricals, we're gonna learn in let me see, in the 2.2. No, 2.2 is still numerical. So yeah, from 2.3. So this is going to be from 2.3. You're going to learn that. 2.1 and 2.2. Okay. So we're going to summarizing important feature in numerical and categorical distribution also in this chapter. So let's move to section 2.1, right? Okay. All right. And as stated before, we're gonna visualizing variation in numerical data 2.1 here. So in this 2.1, we're gonna exploring distribution of numerical data by using dot plot, frequencies, relative frequency histogram, and stem plot. Okay, so let's move to the next slide. So let's talk about what is distribution. Okay, so let's recall what is a distribution. First, any collection of data will have variation within the data. Okay. And the most important tool for organizing the variation in the data is called distribution. Okay, so most important tool organize. Let me use the other color. So let's say you blue one. Most important tool for organizing the variation in the data is called distribution. Okay. So distribution of a sample organized data into a list by recordings such as like all the value observed and the number of time X value was observed. We call frequency. I'm gonna put it up here. Say distribution a samples organized the data into the list by recording. Right. So you need to recording first all values observed. And then secondly, you're gonna record the number of times each value was observed. Record frequency. And okay, so we have a definition of frequency in here, right? Which is the number of times each value was observed caught, right? Okay, so three main components of the numerical distributions gonna be shape. What does it look like, right? Center, with the typical values of it. It could be the mean or the average, something like that, right? It could be the average. In this class we call mean, or could be median. I'm gonna talk about that later, right? And the last component is gonna be variability, which how horizontal spread. This could be using standard deviation or IQR or the range, something like that. So yeah, right. And so on. I'm gonna talk more about that later, but basically right now I just wanna introduce a little bit about that. Okay, so let's move on to the next slide. Number 5. So let's have some example about distributions. Okay. So as you see, here are some raw data from the National Collegiate Athletes Association, so NCAA. This is also available online, and this set of data shows the number. It shows the number of goals scored by the first year of NCAA female soccer. And it's in Division 3 in 2012 season. And keep in mind that the distribution record all observed data values, right? And seeing patterns in the raw data may be difficult if we just don't organize. And in this case, actually, is organized for use always from the lowest to the highest, right? Has been it has been organized from lowest to the highest. Okay. Okay, so let's see. So let's move to the next one. All right. So now, like I said before, distribution of sample organized that the data into the list by recordings. The first one is all value observed. The second one is the frequency, right? So So here is how frequencies, meaning is frequencies. Let me write up. Frequencies is all the odd data's values with their counts. Or like I said before, is the number of times each value was observed, right? So if you look at say number 9 here, right, is have like it's have one observed from 9 there. So what does that mean? We have let me see. Let me go back to the previous slide. It's a, as you see, you have only one number 9 in the list here, right? Okay. So it's mean like you have 9 goals score by one player for the by the first year NCAA female soccer, one female soccer player in there in 2012, yeah, right? So we have like 1, 2, 3, 4 11 goals. So that means there's 4 players that have 11 goals, right? So that's the reason why I have frequency for 11 is 4, right? See that? Okay. So, right. And so on. So like 12, I have only 1, right? So that is what that is a reason why how we why we say like frequency is all the data values with their count. Okay. So so keep in mind that the frequency have been provided on the tables, and the pattern may still be difficult to see. Okay, from the frequency table. It is frequency table. Okay. So what we're gonna do? Let's move to slide number 7. Okay, so examining a true distribution. When examining distributions, use a 2-step process. So the first step is visualize the data. So you visualize the data. So you're gonna use a graph that effectively summarizes the data. Okay. Using a picture to display the data will help us to see pattern. And graph for numerical data includes, could be like dot plots, histogram, and stem plots. Okay, so like I state in the first slide, it's for the numerical data we're going to use mainly it's about using dot plots, histogram, and stem plots. Okay, so so basically the first step is how to see it, right? How to see the data, the graph by a graph, right? Okay, so let's move to the second step and see what happened. Okay. Okay, now in the second step, I need to summarize the data, right? Summarize the data. Right? How to summarize? Okay. Look at the shape. Is that symmetry? Okay. What is center of that? So you need to know, is there a most common value? Most common value. And the spread of it, right? how aren't any data values far from the rest, right? So this is like a unusual thing, right? Is there anything like are there any unusual data values compared to the rest of the data, right? Okay, so that's a spread will help us to do this. Okay, so let's move to the next slide. Okay, visualizing data. Want to go in here. Please keep in mind that using a picture to display the data will help us see the pattern. Okay, so help us see the pattern. Okay, the different visual representation capture different aspects in the data. All right, and the picture must record the data values, right? Again, it's record the data values, and it indicate the frequency the data. So that's how many times each value occurs. Okay, so I'm gonna move to the next slide. So let's take a look at the dot plot. How it look like, right? How can you make a dot plot? And you see, I have the value tables, the value column in the left hand side, and I also have frequency column in the right side. So this is called like frequency tables. According to the frequency tables, how can we create a dot plot? You're gonna record the data values on a number line, and with a dot above the number line for each data values observed. So as you see in here, for examples, there is a dot over here. So what is that? Oh, that is number 9 value. Can you see? Right, and you have only one frequency for the number 9 there. We give you only one dot. Does that make sense to you? And I would say the three dot over here, 4 actually, right, is present for the data values 11 here, right? And this have like 4 dot because of 4 frequency. Does that make sense? Okay, and so on. And you see far away, I saw a dot that's like, you know, alone, like far away from mainly all the data is stay in the left, and there's a dot that's just so isolate in the right hand side there, and it's look like, oh, this is unusual, right? Unusual. Okay, so let's see. In the next slide. All right, so I have another example for dot plots, right? Oops. We're gonna try to answer according to this dot plot. We are trying to answer how many textbook cost $150 or more, right? Okay. And then what percent of the textbook costs $50 or less? And are there any unusual, expensive, or inexpensive text? So for the first question, I would love to look at the price that's 150 or more than that. That means I'm gonna just stick with how many dots from 150 or above, right? And you see that I have right now how many dots? 1, 2, 3, 4. So 4 dots, right? 4 dots. Which means I have 4 textbooks, right? 4 textbooks. That's cost $150 or more. Right? Does that make sense? And the second questions, so I'm gonna say here's 4. Right? And for the second question, they say what percent? Okay, so percent. So what percent of the textbook cost $50 or less? So in this case, we not only look for how many textbook that less than or equal to $50. We also have to find the percent of them by the total of everyone, right? So you have to look for, like, first you have to look for how many no, let's write the formula. So I say number book cost 50 or less, right? You need to have this number, and then you use this number and you multiply by the total. Okay, so let me put it up here. And then you need to let me make the division here. And then you need to divide, I need to multiply it by 100% to make percent, right? Because you are trying to have percent of the book. So this is the formula to handle the question with percent. So you are working on the cost $50 or less, then find the number of book cost $50 or less, and then divide by totals of them. How many books totally, and then you multiply by 100%, and you get the answer. Okay, so think about how many books that 50 or less. You have to count, right, from 50 to the left, right? I see that about 1, 2, 3, 4, 5, 6, 7, 8 dots. So that means I have to have like 8, and then divide by a total. How many totally? How many dots totally do I have, right? So so that was 8, and then 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 plus 4 dot, gonna be 23. So divide by 23, and then I multiplied by 100% to get the answer, right? I mean, you multiply by hundreds, the percent there are going to be the unit of it. So don't click the button percent again if you cover it. Yeah. So I'm going to show you by using calculators for that. Let me open it. So using 8 divided by 23, and then multiply by 100. You got 34.78 percent in two decimal place. Okay. So I will say 34.78. So 34. That's the answer. And they say, are there any unusual, expensive, or inexpensive text? I would say there is one that's like far away from all the data values, and I would say this guy, the last one there. Okay, so the this one. You say unusual. Expensive, because this is more this is the most expensive and expensive more than all the other. So could be, I would say $290 around that. Okay, so that's from estimating. Okay, so that is in order to handle the example here. That's what I do. Let's move to the slide number 12 here and see the solution, right? So as you see, we have 4 textbook costs, 150, right? Okay, we have 8 divided by 23 multiplied 100%, we equal to 34.8%. They round to one decimal place. We got like we got only 34.78%. We round to two decimal place. So that's how different. And the textbook that costs close to $200, so we is the last one over here, right? Gonna be the unusual expensive. Okay, so we move to the next slide, number 13. We talk about the advantage of the and the disadvantage of the dot plots. So keep in mind that there is some advantage and disadvantage of dot plot that you need to consider. If you think about advantage is show individual data values, so that means if you investigate the shape, that means it help you to investigate the shape of the distribution, and for the disadvantage in here, you can say I can say not as common as histogram. We will learn histogram later, but you know, first it's not as common as histogram and other graph. And one more thing is not great for data with too many individual data. So as you can think about what happened if I have like so many data values, such as hundreds or even thousand data values. Are you going to try to put all the dots in there? Well, that's going to be a lot of work, right? So so for the dot plots, I would suggest using with, you know, with few data values. Okay, that can, you know, can have some advance of it. And also, I mean, I should also list one more thing for the advantage in here. It could show it could show equals see, you can say it's easy to spot the unusual, right? Unusual data value, right? Okay, so the main disadvantage gonna be if you have too many data value, that's gonna be problems. All right, so now let's move to the next slide. Okay, let's talk about histogram. So now as we move to histogram. Okay, so we did talk about dot plots. All right, that's an option for for few data values. Histogram is similar, but if can group the data into intervals, and in this course we call bins, and what the bin it is width of the interval, and we call it bin width. Okay, so so in some other some of other statistic people, they call this as class width, class width, right? And the bean is called a class. Same meanings, but just using the other word. All right, so for histogram is count how many data values fall into each bean. How many data values fall into each bean? So that means each class or each bean you have an intervals, right? For example, like if I'm talking about the age of the class, I can split the class, become some classes, and one class was, let's say, in between like 18 years old to 23 years old, something like that, right? So that is for one bean, right? One bean. So instead of just focus only one number like dot, like you have 18, you have only dot in there and put in there, right? It's very specifically for dot plot, but histogram you can group it. All right, so each rectangle has following properties. First, consecutive beans touch. The first value in each bean is recorded on the horizontal axis. So first values in each bean is recorded on the horizontal axis, and the height of each rectangle correspond to the count, which is the frequency. All relative frequency. Relative. Depend on what we are talking about. Okay. Okay. So consecutive. I mean, for the consecutive bean touch, you should understand that since we split, as we group the data into intervals, so then it could be like from 18 to 23, and then the next bean gonna be 24 to to someone else, such as like 24 to 28, something like that, right? It must touch each other, something like that, right? Okay, so let's move to the next slide. Oh, by the way, let's move back to here. And to talk about frequency, someone will say, "Oh, what is the relative frequency, right?" So let's say, okay, so frequencies. Frequency is what? Frequency is how many time you count the data, right? Like how many the number of time data time each value was observed. That is a frequency. So you now can see another one we call it frequency, relative frequency. So what is that? Relative frequency, actually you're gonna be you're gonna use just frequency and then divided by the sample size. Frequency and then divided by sample size. Like how many the number of frequency and then divided by the total how many that's funny. Okay, so that's called relative frequency. All right, so now we can move to 15. Okay. Okay, so here's an example of histogram, right? And you see, we keep working with example number 1, but now instead of having like a dot for each value, I can using like a bean, like a class that includes up to these values for for one class, right? And I know that it includes 1 and 4 here, so that's totally is going to be 5 frequency for this range. So that's the reason why the first of my the first bar in here for the first beam, I must have the height is 5, right? And so then the next bar, because I'm using beam width is 9, 10, 11. So that means, you know, beam width is beam width in here is 3, right? You can do like you can using the way as like the next step gonna be 12 in minus 9, right? 12 minus 9 equal to 3. So that's gonna be that you can get to you can get a beam width. So so the keep in mind that this number 12 here is not included into the bar, the red bar there, right? The value from 12 to 15 is included in the next bar, right? So let's say from 12 to 14 is includes the next bar that will be that's going to have 9, that's going to have 9 frequency. So that's the reason why I have 9 in here, right? And I will have to using the blue one, actually is what the blue, so I can, right? And then the next one could be like 15, 16, and 17, but you can see that there's no 17 in on here at all. So just do 15 and 16 here, and you count like how many frequency do we have. Actually, it's gonna be 2 plus 4, which is 6. So then that's the reason why here 6, right? And that's the reason why we have the bar from 15 to 18, but not include 18 there is 6. All right. So and so on. So you will have 18, 19, and 20 there. All right. So you play one. Okay. This is 6 again. Okay. It's 6. And now as we move to 21, 22, 23, right? 21, 22, 23. That's going to be let's say the orange one. So 21, 22, 23, but you don't see any 20 2 and 23, so it's just gonna have only one for the bar of this interval. Okay, what about some one from 24 to 27, right? No, there's nothing there, right? So that's the reason why I have like a blank here. 27 to 30, no, nothing there, right? 30 to 33, nothing there. Okay, for what about 33 to 36? I have one guy because I'm gonna use what else? Bring one. Right? I have the 35 that have that into this bin. So that's why I have one. Okay, so that's gonna be it for 15. Okay, so let's move to the next slide. Okay, so you are gonna think about, oh, so in this example, I'm using bin width equal to 3. Why? Right? Why are you using bin width is 3? Why not like 5? Why 4? Why that's less than like 2, like 1, something like that? So let's keep my that bin width is my choosing. Okay, it could be different. Could be like 1, 2, or 3 or 4 or more than that. But depend on what you want and depend on you see the how detailed you want to see the graph. Okay, so in this case, my personally say for 3. Is okay because I can still see in a like a general picture of the data value, and I can still see the unusual one there, right? So so what about if you want more detail, right? So I would say you want to change the the bin width to be less than that. So the more less, the more detail the class width is. Okay, so in here in this case, I change to be bin width is 1, and you see over here bin width equal to 1, right? So that's the reason why for the one like from 9 to 10 in here, right? You see that it means that I just have I just have only one number. I just have the only one number from 9. That's not includes to 10 in there, right? So so that's the reason why I have only one from the value 9 there, right? And and you see 10 doesn't have anything. 11, oh, I have 4 11, so that is for 11 here, right? You see that that's I mean clearly these same or similar look at the dot plots when you have bin width it's just 1, right? However, for the bin width that's very small like this, is I mean it's detailed, yes, but think about if you have like a lot of data values, right? Such as hundreds one, 1,001, right? You don't want to do by this way. That's gonna be like too much detail, and it's like gonna be so exhausted to handle the graph, histogram graph. Okay. Okay, so look like it's very detailed. Well, in this case, right? same or similar or same same shape with dot plot. Okay. Okay, so let's move to the next slide. Delete this. 17. All right. So note about bin width, right? A width that is too narrow show too much detail. Like, you know, like you see the case that like it bin width is one only, it's gonna give you like very much detail or too much detail. But for the case, if you say if I using like too wide, right? Too wide. It's like, for example, for the case for the case of the previous two the previous example here. Let's say if I'm using the bin width as like 30 or maybe yeah, say 30, you can see that, oh, that means from 9 to, you know, to 30 38, right? No, 39. So you will have everything in one bar, right? If I draw a line here, right, and then you say here is from 9, and then the next one with 39 here. So that means you have just one bar, and and the frequency of it's going to be just, you know, everything's total 23 I remember, right? So so that doesn't show you like enough detail to understand what is what's what the typical of the graph look like, and what is unusual one, right? So so that's the reason why it's depend on like depend on how many data values that you have, and then you have to check with the bin width, what bin width is reasonable for you to choose and make the best histogram for this case. Okay, so okay, so for doing, like, for graphing histogram in this class, I will teach you using GI84 and StatGrunch to handle that by choose bin width for an initial look as the data, which is the smallest one, and then but one should always experiment with adjusting bin width, right? We should adjust the mirror to see if anything interesting appear. All right, so we see some advantage and disadvantage of histogram. So advantage is good for the large data set, as you see, and then help to focus on the general shape of the data, and then easy to spot the outliers. But the disadvantage for some individual data value that's not visible, it could not visible if you using, you know, using the bin width is more than one, right? So so it's for the individually you don't want to see it anymore. But and also the distribution shape affected by changing in bin width, right? So if you change the bin width, it changes the shape of the distribution. Okay. All right, so let's move down. All right, so I'm going to show you by using TI-84 or TI, I mean, I'm having only TI-83. Hopefully In the future, I have TI-84 to grab it. So let me show you. First, you need to input some data into the list by click to start here, right? And then you will have to enter it and put out all the values for the research for the data values that you have researched. So let's using the data that we have from the examples here. We're talking about the NCAA and the whole score by the first year, right? So put down all the number, say 9, for number 11, right? 12, for number 13, find number 13 actually. So I have 1, 2, 3, 4, 5, right? 5 number 13, I'm gonna make sure 1, 2, 3, 4, 5. Okay. 3 number 14, 1, 4, 1, 4, 1, 4. 2 number 15, 1, 5, 1, 5. 4 number 16. And 2 number 18. 2 number 19. 2 number 20. 21, 35. So that is all the data list, right? Now come back with the instruction from TIs. Okay, so you will have clicks. So after edit and input all the data in the set L1 here, right? So we put second and y equal to second and y equal to. So this one. So as you see, what second here is the 0 button. So that's help you to try to get into the 0 things option here. So we is stat plot, right? Click on this. Okay, so you see now you are in stat plots, and number 1 here you enter it. You need to make this button on here highlight. So that means you need to on it. Right now it's in off. So highlight it by enter it. Okay. And then you gonna go down to the type, right? And go to the histogram graph here, right? So this is the one that we're gonna use over here. And then enter that. And then now they ask you, hey, is that XList is from the L1? Yes, it is your data value. So make sure you are using L1, right? It is L1 already, so we can just leave it like that. Frequency you should leave at default at there, right? And then now you want to push graph. Okay, graph. And then now it looks like something that's appear, but not really quiet. That's quite it's not really like we did see as before, right? We're gonna move to the zoom over here and click on 9. We can zoom start over here, right? Enter that. So as you can see right now, we have a histogram here. To see like week 1 placement for like week bar in here talking about, we may need to click chase and see. For the first bar, it have minimum is from 9, and the maximum is right now is 13, less than 13.333 something. So that means look like we are using five, no, 4, more than 4 a little bit as bandwidth, right? And we need to change this a little bit because I will say this is not really enough detail. Let's say that, right? You want to make it only bandwidth at 3 as the graph like we did before, right? So let's click on the window here. And you can see that I'm starting from X mean was 9. Okay, that was the minimum values. The maximum you can leave as 39. That's okay. Or more than, I mean the maximum before was 35 for the data values. But we don't have to adjust this yet. We're just going to worry about the X scale in here. The X scale in here is actually the bandwidth. So it's going to be 3. Right now, we are choosing as 4.3 something, right? So we choose 3 and see what's going on. For the Y minimum, well, I would, you can do it from negative, but I would say we can even start from 0 because who cares about negative. And then the Y max, you can go up to more than 12 because the max the max frequency could be more than that. So I would choose like 15 to make sure I cover everything. Remember that the Y or the vertical axis is a frequency. So that's the reason why I choose like about like 15. It should be it should be like cover everything. Okay, so let's click on the graph and see what's happened now. Sorry. Okay, now you can see that the graph look more detailed than before, right? And you see if, I mean, maybe we need to chase a little and see what happened with the last one. So chase, and then go to, so you can see the highest frequency was 12. Yeah, so you can go up to 12.5. That's fine instead of 12. Instead of 15, right? And for the minimum, for the outlier over here, we have from 33 and up to 36. So that means we don't have to care the last interval over here because there's nothing here. Okay, so I'm gonna just start as 36 for the X max. Okay, so let's go to the window again, and then I change the X max to be 36. Okay, and then I change the Y max to be 12.5 to make it perfect. Okay, now graph. Here we go. The graph is more detailed and adjust really enough for you to see clearly. So so this is good practice for the TI 84 on create the histogram. So please practice with it. Okay, so now I'm gonna move to stem plot. All right, so let's see. So stem plot it's also called stem and leaf plot. Okay, using, all right, and it's like a dot plot. It show all the individual data values. The useful when technology is not available. So in the case that you don't have, TI stuff or technology stuff, your stem plot is one of the good idea to do for present the data. But it will not, I mean, it can be a problem if the data is large. So it's help you only when the data set is not too large. Okay, similar with the plot. All right. So now I'm gonna move to the last slide and show you an example about stem plot. So let's say I have the data list here as 111, 222, 222, right? So for number one, right? For number one, 3 number 2, how many number 3? 4 number 3, something like that, right? And so on. These have been this list have been the data list has been organized, organized from small to large. So that can help you to start with a list of data is organized from small to large. All right. So now for the stem and plot for of this data, you start with a stem, which is the first digit of all the list data in here. In here, the highest number, the maximum, the highest number have 2 digits, right? So the first digit is gonna be the 10, right? So as you see, I'm gonna convert all the data values into 2 digits. So 1 can be rewrite as 01, right? Can be rewrite as 01, right? 2 can be rewrite as 02, something like that, right? So that means what? I can write again, have it again on here. So 01, comma, 01, comma, 01, comma, 01, comma, 02, comma, 02, 02, 03, 03, 03, 03. How many 3? 4, 3 or even 4, 3. Actually 5, 3. 03, right? Something like that. And so on. And until like for the one with 2 digits, such as 10, 10, 15, right? I keep it at the same 2 digits, right? And then up to 40. So, and you see right now, I can start with the stem plot. By the stem is the first digit for the one that's from 1 to 10, from 1 to 9, right? I'm gonna using the stem as 0, right? Weak mean all the leaf of this stem will be for all the data from 1 to 9, right? And you see that I have let me delete this. I have all of this number is in stem 0, and I put them in together for a stem, and the leaf is exactly those number, right? For the second stem, I'm gonna start with a 10 with the stem as 1, right? And you see that means number 10 there can be stem is 1 and the leaf is 0, right? So I have 2 number 10 that make 2 number 0, and I have number 15 that make leaf is 5, and 17 that make leaf is 7 for the stem is 1. So and so on. We go by that way. For the third stem was 20. Oh, actually, right? So 20, 25 gonna be the same in the same stem as 2, and gonna be 0 and 5, right? And 30 gonna be in the stem at 3 with 2 0 leaves, right? And the last one gonna be 40, which stem is 4 and leaf is 0. So that is a way we create a stem plot. All right. So I'm gonna start the stem plot in section 2.1 here, and see you in the next section.